Okay, so we've got a question here. Find the limit as x approaches 0 of this function here, sine of x minus x divided by x cosine x minus x. Okay, let's go straight away, plug in x equals 0 into here, see what happens. So this leads us to sine of 0, that is 0, minus x, which is 0, and then 0 times whatever cosine of x will always be 0, and then minus another 0. So 0 over 0 situation, obviously undefined, so we need to find a solution with some other method to try and find the answer to this question. Now the way forward is going to be Hopital's rule, because as we've got a 0 over 0 situation, this is one of the conditions for when using Hopital. The other one is that this denominator and numerator are both continuous and differentiable, which obviously sine, cosine and x always are. So what we do is we say the limit of x approaching 0 of f of x divided by g of x. So we assign denominator as f of x and denominator as g of x. Just put that in brackets for you so you can see what we're going to do. And then we say that equals f prime of x over g prime of x. Hence the rule with derivatives and also continuous. So if you find the derivative of top and bottom, this may lead us to the answer. So let's find the derivative of the numerator first. So sine of x, that gives us cosine of x, and x just gives us 1. Now we've got x cosine of x, which we'll need the product rule for, and also we've got minus x. Well, minus x we know is going to be minus 1. So let's find the derivative of x cosine x using the product rule. So x cosine of x, so using the product rule, you leave x as it is and multiply that by the derivative of cosine x, which will be minus sine of x. So let's bring the minus out here and put sine of x, and then add that to the derivative of x, which is 1, and just leave cosine x as it is. So if we write cosine of x minus x sine of x, that's our derivative of this function here. So cosine of x minus x sine of x, and then minus 1. Okay, let's plug in 0 into this function here now, because as the limit is approaching 0, even though we've taken the derivative, we still want to plug in 0 for our x's. So cosine of 0, that's 1, and then minus 1, that stays. Cosine of x, well, cosine of 0 is also 1. X times sine of x, well, that's always going to be 0 because x is 0, so minus 0, and then minus 1 again. So this now leads us to 0 over 0 situation again. So what do we do now? Well, what do we do now? We go to the next stage of Hopital, and now we find the second derivative. So now we can say that we now need f double prime of x over g double prime of x, having reached a 0 over 0 situation. So this is a valid way we can do this. So now let's go on, find the derivative of these functions. So the second derivative of this will be the derivative of this. So cosine of x, derivative of that is minus sine of x, and the derivative of minus 1, that disappears, that just becomes 0. So I'll just put the minus 0 in there so you can see it. Okay, denominator cosine of x, as we know, is minus sine of x. Again, derivative of minus x sine of x. So let's go over here and do the product rule over here. Minus x sine of x, almost the same as here. Again, break down our functions. So minus x we can keep. Take the derivative of sine, which is cosine, then we add that to minus x becomes minus 1, and then sine of x stays. So what we're left with now, we could put minus sine of x minus x cosine of x. Okay, so we've got a minus sine of x here, minus sine of x here. Let's put that down as minus 2 sine of x. And then minus x cosine of x. And then the minus 1 derivative of that disappears. I'll put the 0 in there so we can see that we've done it. Okay, let's plug in 0 now for all these values here. So minus sine of 0 is 0, minus 0. Minus 2 times sine of 0, again that's going to be 0. Then x times cosine of x, again that's going to be a 0. And then the other minus 0. And again, we're left with another 0 over 0 situation. Got a feeling this might go on forever. But anyway, if we keep persevering, eventually one of these is going to come good for us. So what we do is now we take the derivative again. So now we can take the third derivative of the functions. We could just put the 3 here, but I'll put the 3 bars there so we can see what's going on. Okay, again let's take the derivative of this, minus sine of x. So derivative of sine is cosine, so now we've got minus cosine of x. Minus 0, we can get rid of that now. 2 times sine of x, well derivative of sine is cosine, so that becomes minus 2 cosine of x. So that's that. The minus 0 we'll get rid of, but now we've got the x cosine of x again. Well, we did that here, but we're just going to put a minus sign in front of it. So if we use this and put a minus sign in front of it, we'll end up with x sine of x minus cosine of x. So plus x sine of x. That will obviously change. Then we change this sign here, obviously because we want this minus sign in. So the minus will be distributed to both functions. So x sine of x becomes positive, and then a minus cosine of x. Okay, now let's plug in 0 for these values. Minus cosine of x, so minus cosine of 0, that becomes minus 1. Now we're looking good. It looks like we're going to get a solution here. Okay, minus 2 cosine of x minus cosine of x. Let's just write this down now as minus 3 cosine of x. Cross this function out. We don't even need the minus sign either. So minus 3 times cosine of 0 becomes minus 3. And then the x sine of x, well x is 0, so that's always going to be 0. So plus 0. Okay, so now we can simplify this. Looks like we've got a limit here. So we've got minus 1 over minus 3 just becomes 1 over 3. Okay, now that, after all these calculations, it's like a derivative question almost. That's the limit of this function as x approaches 0. We get positive 1/3.